Hey, hello physicists, what's the crack? So today we're going to do a quick question on potential dividers because I think Neil requested it. Okay, so if we look here, we're told what the EMF is of our cell and we're told there is an internal resistance. So when you get these questions, I think it's smarter to always add in your little internal resistor and then do like a little dotted line around it so you know that that internal resistance is there, so you don't forget about your math, and you know that it's inside the cell, okay? So what we're told is from A to B is going to have 125 ohms. So I'm just going to write down on that, 125 ohms. Our sliding contact, what we can do is we can change the resistance, right? If I put my sliding contact at this point, what's happened is I have my electrons. If my voltmeter's got infinite resistance, none of them go through the voltmeter and all of them go with 125 ohms, right? So what I can do is I can move this contact to different points to have different amounts of resistance, okay? So what it says is we're moving the contact to the moving contact is moved to B. So we're moving up to B. So what we're doing is we're having a voltmeter across the full resistor, okay? And the switch is closed and we're told the voltmeter reads 2.89, okay? So I want to prove what the internal resistance actually is. So I'm trying to find what that little resistor is. Okay, so the question I know to do with internal resistance on my data sheet, if I just rearrange it, I get V equals E minus IR. Okay, so what this equation tells us, if the current is zero, so if there's zero current flowing from the circuit, the potential difference will equal the EMF. But if there is a current flowing through the circuit, the potential difference will always be lower than what the EMF is. Makes sense? The EMF, 3 volts, is the maximum the battery can give. But because of the internal resistance, there will be some lost PD, some lost energy in the cell itself before the electrons get to leave. Okay, so what I'm trying to do is show what that R is. So I know what V is because I know if this technically is a parallel circuit now. So the potential difference across this component will be equal to the potential difference across this component. So I know V is 2.89. That's going to equal my EMF. My EMF is 3 minus I times R. Okay? I'm trying to find R, so I must have I somewhere else in the circuit. So look at my circuit and what information I'm given again. I'm given the resistance. So I know that capital V equals capital I times capital R. Okay, so capital V, this is my GCSE stuff. So I know my voltmeter, which is 2.89, equals some current times the resistance, which is 125. So to find the current, all I need to do is my 2.89 divide it by 125. Divide both sides by 125. To get my current is 0.02312 amps. Okay, so 0.02312 amps. So now all I'll do is plug that number in here. So what I have now is 2.89 equals 3, take away 0.02312 times by little r, okay? So to rearrange this, what I can do is I can add this number to both sides and subtract this number from both sides. So what I can have is 0.02312r is going to be equal to 3 minus 2.89. So all I do then to find R is I divide both sides by 0.2312 to get a final answer for my little r, which I'm just going to write here. My little r, or my internal resistance on my calculator, comes out at 4.75, or my calculator anyway, 4.75779. And the question asked me to prove it's 4.8. So I want to show the examiner how I know that's equal to 4.8. So I know R will equal to 4.8 if I write that number to one decimal place, because that 5 will make the right number before it round up, okay? So again, this question is looking at internal resistance, and you had to use the other information first to find the current, okay? So this would be looking at your 4 or your 5 mark question, okay? So that's grand. Follow me for more physics content like this.